So this particular train air conditioning manual, okay, it will give you the complete detail how to understand all the heat cooling load estimation, okay, each and everything. Like if you go to the heat conduction through the surfaces, okay, like through the wall, okay, through the wall here, how, okay, what is the U value, how to do the U value calculation. Can you see the material? U value, concrete block,
Yes,
aluminum siding, gypsum
aluminum
board, insulation, wood studs. So
solution.
these each and every material having a resistance. Okay, say for example, you have a paper. Okay, paper means the heat will be transferred from one place to another place very easily because it is a thin paper, right?
Correct. Yes.
So the resistance is very less resistance. But if whereas if you go to the brick, okay, you have a more resistance. If you go to concrete, you have much more resistance. Correct.
Yes. Correct.
So that is only the U value is deciding. Okay.
Mm-hmm.
And if you see the equation Q equal to UA delta T. So this value only you are entering in the HAP software. So and see the how to calculate the U value example or each and every value having a thermal resistance.
Yes. Yes. Yes.
Okay. So based on the
This U
thermal
value engineer.
resistance, yeah.
Sorry. For this wall U value engineer, normally this one is not just the constant, right? For example, in one room it is air conditioned, is conditioned air, and then the other room is not conditioned air. The U value of this wall is maybe different from the other wall, right?
No. It will be same.
It will be the same.
It will be same. Yes. See, you are talking about what is the resistance of the material. The material resistance will not
Okay.
change, right? Internal or external. Okay. But when you see the material, see, for example, what normally they do when you see the in external material, okay, external wall, they will add some insulation to reduce the U value. Correct.
Okay.
But if
Okay.
you go to the internal wall, they don't need insulation because both sides are air conditioning. Correct.
Correct. Okay.
So you
Okay.
don't
I get
require
this one.
insulation, but so in that case, the U value will be different, but it is not depends upon the temperature.
Okay. They will just add. They will just add if it's
Yeah, they will just
external,
add.
right?
Yeah. External means they will be adding some insulation. Can you see here insulation?
Yeah.
So insulation means you have a more resistance, correct?
Correct. Correct.
When you have a more resistance, then your U value will reduce. Okay.
Yes. I know. I've read
Okay.
this one
Yeah,
over
but
here.
when you go to internal means you have both side air conditioning, correct?
Correct. Yes.
So you don't require insulation.
Yes. Yes.
So what will happen? U value will increase or decrease if you remove that
It will
insulation.
it will decrease, right?
No, if you remove the U value if for the, sorry R value for the insulation, your U value will increase or decrease.
So if the U value will be 1 minute, I will think of. So the R value is the resistance value, right?
Resistance value, yes. If more resistance,
So the
less U value.
more resistance, yes,
Mean
less
less
U
U
value.
value.
Okay.
Okay. So if you remove the insulation,
Ah,
what will
ah.
happen? The R
So
will
there's
reduce,
the okay. So the U value will increase like this.
will increase. That is why whenever you see the
Ah. Mm,
architectural U value, architectural schedule for the U value, you will find external wall 0.39.
yes.
But for internal wall, you will find 2.2.
Okay.
Why the difference? Because they don't require insulation for the internal wall because both sides are conditioned space. You don't need to provide insulation. But if you go to external wall, you need insulation because there are lot of heat coming from outside to inside. If you don't provide
Correct.
insulation,
Correct.
lot of heat will be enter into the space. Then you need a much more higher equipment, in, higher
Correct.
air conditioning machine. Correct.
Correct. Correct.
So to reduce that one, you are adding the insulation. Okay, and you can also go through the shaded wall. Okay, this is the sunlight. Okay, through the sunrise, you are getting the heat. So this is the same equation, CLTD. Okay, then
Okay.
depends upon the facing. This will be calculated automatically by your HAP software. Okay, the
Correct. Yes.
cooling load
Yes. Yes.
temperature difference. You have windows, U value for windows, solar radiation through the
Yeah.
glass. Okay, you will this will give you the detailed study. Okay, how to operate app software. It is not that just you open the app software, you enter the value, you get the result. Not like that. If you read this particular document, you will really understand. Okay, what is shading coefficient? You can see the value here. What is shading coefficient?
This
Okay,
shading coefficient is, yeah, okay. For
what is
the
what is solar?
this
What
window
is
here.
solar? Yeah, yeah.
Okay, this window U value engineer.
Okay,
Normally this is just the same with the wall, right? So for the resistance, like for example, for the car, they're putting something to just save, or what you call this one.
shade. Yeah, yeah, yeah.
Um,
Correct. Yes, that is a here. That is
this
here. That is here. Can you see here? This is the shading coefficient, like clear glass. If you have a clear glass, what is the shading coefficient?
okay, yes.
Okay. So if you have a reflective single glazing, reflective double glazing, okay.
Okay.
So here they are adding some coating, like for example, this is the clear space, clear glass. About the clear glass, what is the U value? If you add the shading, okay, and what is the U value?
Mm,
See the values here. Uncoated double glazing. Okay, then
okay.
they have a
Yes.
reflective single glazing.
Yes.
Okay, so here they have given the detail here. What is that? Uncoated double glazing, reflective glazing. Okay, then shading, solar radiation through the windows.
Okay. But
See
this
here,
train, but
here
this
this is the
train,
shading
this
devices.
is
This is the shading
yes,
devices. Can you see? They provide the shading. Shading means
yes,
like to reduce your hot coming from outside to inside. Okay. See here, can you see that
yes.
exterior
Okay.
fins with a different color? This is the shading.
Yes.
Can you see here? Installing internal shading devices such as ventilation blinds, curtains, or drapes can reduce the amount of solar energy passing through a window.
Okay.
The effectiveness of these shading devices depends upon their ability to reflect the incoming solar radiation back through the window before it is converted into heat inside the space. So, light colored blinds
Um,
or drapes lined with a light colored material, therefore, are more effective than dark colored shading devices.
okay. Yeah, I get it. Engineer.
Okay, so this is what they are adding the shading, right? Whenever you see the buildings,
Yes.
it's not a clear glass. Say clear glass means you have more heat going to the space. If you have a shading glass, that means you have a less space going to the space. Okay, then you have an
So
internal, yeah.
yeah, this one engineer. So this train is a different manufacturer, right? So every manufacturer they're
No, no,
giving
no,
their
no,
own.
no, no. It's not. No, no. This is not about manufacturer. This is about basics. This is about heat load calculations. They are not talking about their machines. This is a train.
Okay.
Train is a company. They are preparing this. They prepare this manual. Okay. It is
Okay.
doesn't change. It doesn't mean that if you go to different company, we have a different cooling load estimation. No. This is a manual. This is
Okay.
study material.
Okay.
Okay. Heat gain from people. Heat gain from lighting. Heat generated by equipment, how to calculate through the infiltration. See here, there are three different method: air change method, crack method, effective method. How to calculate air change method, how to calculate air crack method. Okay,
Okay.
so it's all given here. And effective leakage area method, how to calculate. Okay, infiltration. There they have also given some sample calculations. Okay, here you can
Okay.
see that
Yeah.
ventilation, outside air requirements. Then cooling load estimations from the machine. System heat gains. What is system heat gain? Remember when you see this one, here, there's a system. Yeah, you can see that there are different heat gains. Where is the system?
System heat gains is this for this motor, right, engineer? For the
Yeah,
motor this
maybe.
dissipation.
Yeah, see, yes, the motor heat dissipation due to the energy lost in the conversion of electrical energies. Okay, so how to calculate the fan motor heat gain? Power input into 1 minus motor efficiency.
Okay. Yes.
This for the fan motor heat gain. So how to calculate? Here you will find all the detailed calculations here. Then how to calculate cooling load estimation for the components of fan heat gain. Okay, if you have a fan before the coil, if you have a fan after the coil, how to calculate heat gain through the duct work. So this the duct work is nothing but this one, duct heat gain losses. So how to calculate? Okay, summary of cooling
Okay.
loads. So you will find summary of heat load, like all the sensible load, all the latent load, how to calculate your total cooling load here, right?
Okay. Yeah.
Psychometric analysis. Okay, so you can calculate supply temperature, how to calculate on coil condition, calculate entering on coil conditions. Okay, calculate entering oil conditions.
Okay.
See the psychometric. This is what you have seen in the carrier as well. Okay,
Yeah. 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 This one.
see determine supply temperature. How to calculate supply temperature here. Okay, calculate how to calculate supply airflow rate. Total cooling load on coil. Okay, see that when you have a room faces west, what is the total heat load? When your room faces east side, what is your heat load? So there is a temperature, there is a difference, right? When you see that
Yes.
west
Yes. Yes.
and when you see the east, both are same, but you have a different conditions, different
Depends upon the locations of
different
your.
output. Yeah, depends upon the your heat going through the solar.
Correct.
Okay,
Yes. It's correct.
yeah. So here you can find out block cooling load. You can see that there is a block. What is a block cooling load? When you go to this one, you will find maximum coil. Okay, you will find the maximum block CFM. Can you see the two different CFMs, for example, sometime? Okay,
Yeah,
you will
engineer.
find coil CFM, you will find the maximum block CFM, you will find sum of peak CFM. So what is that? What is that? The definition is given here. Sum of peak, okay, and block cooling load. So that definition is given here. And heating load components. What are the heating load components inside?
Okay.
How to calculate
Then
design weather
sensible and
temperature? Yeah, this for the heating.
okay.
So far we have seen cooling, and this is for the heating. Okay, how to calculate heating? In case if you are working for different region, you may require heating. So how to calculate heating?
Okay. Okay.
Okay, so you also can create some quiz. You can post it in the group, so people will try to understand what for heating, for cooling, for psychometric. Okay, some quizzes here, right? You also can post the same quiz in the group also.
Okay, engineer.
Okay, so this is about. So if you go to my guideline, you will find all the detail here. How to calculate U values. Okay, there are some design materials you can go through module by module. Okay.
Yeah. Correct. Correct. Yeah.